Hello everyone, my name is Sujith Vadakkepati. I work as a product manager at Oracle, focusing on supplier qualifications, compliance, and risk intelligence. Over the last several years, my work has centered over a simple question. How do we manage supplier risk in a world that no longer behaves predictably? Today's session is not about experimenting with generative AI. It's about putting AI to work inside real enterprise constraints. Most organizations still rely on static rule-based risk models like scorecards, thresholds, and periodic reviews. These systems work only when the risk is low, predictable, and already visible in your systems. But that's not how risk shows up anymore. The earliest and most consequential risk signals appear in unstructured sources like news about labor violations, regulatory enforcements, ESG disclosures, litigation, sanctions, or even geopolitical developments. By the time those signals make it into your traditional ERP systems, the organization is already reacting too late. This is the core problem this framework addresses. What I'm presenting today is an explainable hybrid intelligence framework that combines retrieval augmented generation RAG with large language models LLMs to deliver evidence-based supply risk intelligence. Now, all this without sacrificing on the transparency or auditability. At a high level, the idea is simple but powerful. Instead of asking an LLM to guess the risk, we first retrieve relevance evidence from internal ERP data and external intelligence sources, and then use LLM to reason over that evidence, not replace it. So RAG acts as the grounding layer, and LLMs acts as the reasoning layer. Together, they create a risk assessments that's both context aware because they consider real world signals and adaptive because they update as new information emerges. And most importantly, it's explainable because every conclusion is traceable back to the source evidence. This is the fundamental shift from like static risk scoring to continuous risk intelligence. Instead of asking, what was your supplier risk last quarter? We can now ask what has changed, why does it matter, and what should we do next? And that explainability is not optional. In regulated industries like healthcare or public sector, risk decisions must be defensible. This framework is designed so that every risk signal includes its source, reasoning, and justification that a human can review and audit. So as we go through the rest of the presentation, I'll walk you through why traditional models fail in dynamic environments and how this hybrid RAG LLM architecture works end to end. To understand why a new approach is necessary, we need to first look at how supplier risk is typically assessed today. Most organizations rely on traditional risk assessment models built around structured data and predefined rules. Uh, think about scorecards, thresholds, certifications, and compliance checklists. These systems were designed for a world where risk was relatively stable, data was clean and structured, and supplier environments changed slowly. That world no longer exists. Traditional models focus almost entirely on what is already known and recorded, like the financial results, audit results, performance metrics. They assume risk is something that you can measure at a point in time, and then you can revisit it on a periodic basis, like maybe every quarter or annually. The problem is that real risk doesn't behave that way. Risk is emergent, it evolves between review cycles, and it often appears outside your system of record. Early warning signals almost never arrive as a neat data in your ERP tables. They show up as news articles, regulatory enforcement actions, warning letters, trade policy changes, disclosures, or sanctions. Traditional systems simply cannot process this information at scale. They lack the ability to read, interpret, and connect unstructured signals across sources, and as a result, they create systematic blind spots. By the time risk crosses a threshold and triggers an alert, the organization is already in a reactive mode, scrambling to respond instead of proactively managing the risk. Another major limitation is the rigidity. So most of the systems have a rule-based configuration. If X happens, trigger Y. But most supplier risk is rarely that simple. Signals are often weak, indirect, and interconnected across financial, regulatory, geopolitical, and ESG dimensions. Traditional models either miss these signals entirely or overcorrect, generating false positives and alert fatigue. And finally, there's the issue of context and explainability. Even when traditional systems flag risk, they struggle to explain why. Beyond pointing to a breach threshold or a failed rule, that's not enough for high stakes regulatory decision making. So the takeaway is straightforward. Traditional risk management systems are backward looking, structurally blind to unstructured intelligence, and slow to adapt. It is not aligned with how actually risk emerges in global supply chains. This is the gap the rest of the framework is designed to close. When traditional risk models fail, the consequences aren't theoretical, they are operational. The most immediate consequence is late detection. Because conventional systems depend on static data and periodic reviews, they only surface risk after it has already materialized. And by the time a supplier fails a rule or breaches a threshold, the disruption is already underway. At this point, organizations are no longer managing risk, they are managing damage. This leads directly to reactive decision making. Procurement teams are focused into fire drills to find substitute suppliers or costly workarounds to keep your operations running. None of this is strategic. It's expensive, stressful, and avoidable. Another consequence is false confidence. Traditional dashboards often show suppliers as low risk simply because there is no structured metric that has changed. But that green status can mask growing exposure in areas the system cannot see, like regulatory scrutiny, labor practices, geopolitical instability, or financial distress reported externally. So organizations think they are safe until they are not. Then there's risk concentration. Because emerging risks go undetected, organizations unknowingly allow exposure to accumulate around specific suppliers, regions, or tiers. When a disruption finally hits, the impact is amplified. Multiple processes, products, or markets are affected at once. And finally, there's a governance problem. When leadership asks, why didn't we see this coming? Traditional systems don't have a good answer. There's no clear trail of what signals existed, what information was ignored or inaccessible, or how decisions were made given what was known at that time. The lack of explainability erodes trust internally with stakeholders and externally with regulators and auditors. So, the real consequence of conventional approaches isn't just missed signals, it is delayed response, higher operational and compliance costs, greater disruption impact, and weaker accountability when things go wrong. This is why supply risk management can no longer be a static scoring exercise. It needs to become continuous, evidence driven, and explainable, which is exactly what the hybrid RAG LLM framework enables. Up to this point, we talked about what's broken. Now let's see what changes. The innovation here is not just using AI, it's how AI is used. Rather than static rules or an LLM operating in isolation, we bring in an explainable hybrid intelligence by combining retrieval, reasoning, and governance. At the core of this paradigm is a simple principle: no reasoning without evidence, no insight without traceability. The system works in two tightly coupled layers. First, retrieval augmented generation or RAG. Before any assessment is produced, the system retrieves relevant verifiable evidence from both internal enterprise systems like supply performance and compliance records, or external intelligence like regulatory filings, news, ESG disclosures, enforcement actions. This retrieval step ensures that the model is not relying on memory or probability, it's grounding every conclusion in real auditable information. Then comes the LLM reasoning layer. The language model does not generate opinions. It synthesizes, interprets, and explains the retrieved evidence. It connects weak signals across domains, identifies emerging patterns, and explains why a supplier's risk profile is changing. Crucially, every output includes the reasoning path, the supporting sources, and the confidence context. This is what makes the intelligence explainable, not just accurate. What's truly new here is that explainability is not a post-processing step. It's built directly into the architecture. Traditional AI systems often try to explain decisions after the fact. In contrast, this framework ensures that explainability is present in every stage, from retrieval to synthesis, to final risk insight. The result is a system that is dynamic because it adapts to new information as it emerges, transparent because every decision can be traced, governable because humans can review, challenge, and override conclusions. And this marks a shift in the mindset from did that supplier violate a rule to what has changed in the supplier's environment, what does it imply, and what action should we take now? That's the paradigm shift from static assessment to living risk intelligence. And in high stakes supply chain, this shift isn't optional anymore. Now let's look at the architecture at a high level. This framework is designed as an end-to-end pipeline that turns raw enterprise data and external intelligence into risk insights. There are four main stages. First, data integration. We start by bringing together two worlds of data. Internal enterprise signals like ERP transactions, delivery performance, quality issues, contract terms, and qualification outcomes, and external intelligence like news, regulatory actions, ESG disclosures, litigations, and geopolitical events. The point is not to replace ERP-based risk metrics. It's to augment them with early signals that ERP can't see. Second, intelligent retrieval. This is the RAG layer. All of this information is indexed so that the system can retrieve the most relevant evidence for a given supplier or risk question. That retrieval isn't just a keyword search, it's semantic. So if something new happens, say an enforcement action, a recall, or a sanctions related signal, the system can pull the specific passages and artifacts that matter along with the metadata like the source credibility and recency. This step is crucial because it creates ground truth for the next step. Third is the LLM synthesis. Once the right evidence is retrieved, the LLM performs structured reasoning. It does three jobs. First, it summarizes what changed. Second, it interprets impact across risk dimensions like compliance, financials, geopolitical, ESG. And third, it explains the reasoning with citations back to the retrieved evidence. Importantly, the LLM is not freestyling. It's constrained to what it retrieved and it flags uncertainty or missing evidence instead of hallucinating. Fourth is the risk intelligence output. This is what the user actually consumes. So instead of a single score, the output is a risk assessment by dimension, a clear explanation of why risk increased or decreased, the supporting evidence trail, and a recommended next action. For example, initiate a review, launch a qualification, add a monitoring, or escalate. And across the entire pipeline, explainability is preserved. That means the user can go from an insight like compliance risk increased all the way to what documents were used, what passages were cited, and how the conclusion was formed. So the architecture gives you something traditional systems don't. Dynamic intelligence that remains auditable. And that combination, adaptability plus traceability, is what makes this viable for enterprise and regulated environments. Everything this framework does depends on what data it can see. So let's look at one of the biggest gaps in traditional supplier risk management, the fragmented intelligence. Most organizations already have strong internal data. They know how their suppliers are performing inside the enterprise. What they don't have is a reliable way to connect that with what's happening outside their systems, where early signals appear. This framework integrates two complementary data domains. First is the internal enterprise data, and this includes information already trusted and governed, like ERP transactions and payment behavior, delivery performance and quality metrics, contractual obligations and audit results, maybe qualification statuses and the historical outcomes. This data gives us a baseline risk context, how a supplier has behaved historically and how critical they are to the business. But internal data only tells you what has already happened. So the second domain is where the real expansion happens. External intelligence sources like regulatory filings or enforcement actions, news and media coverage, ESG and sustainability documents, financial market signals, or geopolitical and trade developments. These are the kind of unstructured, high volume, fast moving data which typical traditional ERP software doesn't grab. The key innovation here is not just ingesting this data, but making it usable. All incoming data is normalized and indexed, tagged with metadata like source and reliability, continuously updated so assessments reflect the current environment. And what's important is that these two domains are not treated equally. They're contextualized together. Internal data tells us who the supplier is and how critical they are. External intelligence tells us what's changing around them. Only when those two are combined can you get a meaningful answer like which critical suppliers are showing early signs of regulatory exposure, where the geopolitical risk is arising before it impacts operations, which suppliers look stable internally but risky externally. This integration enables early detection without overreaction. Because the system can weigh external signals against internal importance, it avoids noise while it still surfaces real threats. So the comprehensive data integration is what allows the framework to move from monitoring known risk to detecting emerging risk. And that's what makes everything else in this architecture possible. Up to now, I've talked about how the framework works. This looks at what it delivers in practical terms. There are four core capabilities. First is transparency. Every risk assessment is fully traceable. When the system flags a supplier, you don't just see a score or like a score increased or decreased. What you see is specific evidence used, where it came from, and when it was retrieved. This creates a complete audit trail, which is essential for regulated industries. You can explain decisions to leadership, auditors, or regulators without reverse engineering the system. Second is interpretability. This framework doesn't just say what the risk is, it explains why. Risk insights come with natural language explanations that connect signals across domains. That means stakeholders can understand how a regulatory action, financial signal, or geopolitical event affects your supplier's viability. This dramatically reduces the gap between AI output and human decision making. Third is adaptability. Traditional models are static. They only change when someone reconfigures rules. This framework adapts automatically. As new information becomes available, the system retrieves updated evidence and re-evaluates supplier risk in near real time. That means risk assessments evolve as the environment changes, not months later. Adaptability is what enables early warnings instead of post-incident reporting. The fourth capability is responsiveness. Because retrieval and reasoning are automated, the time between signal and insights collapses. Instead of manual monitoring and periodic reviews, the framework continuously processes new data and surfaces changes that matter. That responsiveness allows teams to intervene early, prioritize the right suppliers, and focus human attention where it has the highest impact. Taken together, these capabilities shift supplier risk management from static assessment to continuous explainable intelligence. And the key point is that none of these come at the expense of governance. Transparency, interpretability, adaptability, and responsiveness are not trade-offs. They reinforce each other. That's what makes this framework suitable for real enterprise deployment and not just experimentation. So what does all of this enable that traditional systems simply can't do? The answer is earlier, deeper, and more accurate risk detection. Conventional risk models are built to detect known patterns, predefined thresholds, historical trends, and isolated indicators. They work well when risk is obvious and already measurable. But the most damaging supply risks don't start that way. They begin with weak, fragmented signals spread across different sources. This framework is designed to detect those signals before they converge into a failure. First, it enables multi-factor risk identification. Instead of looking at financial, compliance, or geopolitical risk in isolation, the system evaluates them together. A single signal may not matter, but several related signals across domains often do. For example, a minor regulatory action coupled with a negative media coverage combined with deteriorating financial indicators Normally, they don't trigger a rule, but together they signal an elevated risk. Traditional systems miss that interaction. This framework doesn't. Second, it excels at early stage detection. Because it's continuously monitoring unstructured external intelligence, the system can surface risk weeks or months before it would appear in structured enterprise data. That gives organizations time to engage suppliers early, adjust sourcing strategies, or initiative corrective actions before disruption happens. Third, it reduces false positives and noise. Not every news article or regulatory update is meaningful. By grounding risk detection, retrieved evidence, and contextual reasoning, the framework distinguishes between one-off events with limited impact and signals that materially change supplier risk profiles. That means fewer unnecessary escalations and better use of human attention. And finally, every detected risk is explainable. When the system flags a supplier, just simply say high risk. It explains which signals mattered, how they relate with each other, and how the risk level changed. This is critical for trust and actionability. So the net effect is a system that detects risk early, understands it more holistically, and explains it clearly enough to act on. That's what makes the detection superior, not just automated, but more intelligent. Whenever AI is introduced in risk and compliance decisions, the first question shouldn't be how powerful it is. It should be how do we control it? This framework was designed with governance as a first class requirement, not just as an afterthought. There are four pillars to responsible AI implementation here. First is bias mitigation. Supplier risk decisions can have real business consequences, so bias is not acceptable. The system is continuously monitored for skewed outcomes across geography, supply size, or category. And because every decision is grounded in retrieved evidence, we can inspect why a risk assessment was made and detect patterns that may indicate bias. This makes bias detectable and correctable rather than hidden inside opaque models. Second is human oversight. This framework does not replace human judgment. It is designed as a decision support system, not an autonomous decision maker. For high impact or high uncertainty cases, the system explicitly routes decision to human reviewers, and humans can review the evidence, challenge the reasoning, and override the recommendation. And importantly, those overrides are captured as feedback to improve the system over time. Third is auditability and traceability. Every assessment produces a complete audit trail that includes what data was used, which sources were retrieved, how conclusions were formed, and when decisions were made. This is critical for regulatory compliance and internal accountability. You don't have to trust the system blindly, you can inspect it. Fourth is explainability standards. Explanations are consistent, structured, and documented. The system doesn't generate one-off justifications. It follows defined reasoning templates so that similar situations are explained in similar ways, which is essential for fairness, definability, and trust. Taken together, these governance mechanisms ensure that the framework is transparent enough to audit, controlled enough to trust, and flexible enough to improve over time. This is what allows advanced AI to operate in regulated enterprise environments without creating unacceptable risk of its own. One of the biggest reasons traditional risk systems fail is simple. They can't read. They are built to process tables, scores, and fields, not narratives, filings, or real world events. The earliest indicators of supplier risk live outside structured systems in news reports and disclosures. Traditional platforms can't ingest or reason over this data at scale, forcing organizations to either miss it entirely or rely on fragile manual tracking. This framework directly solves that limitation. At the ingestion layer, unstructured sources are continuously monitored, collected, and indexed. And the system doesn't just store documents, it prepares them for semantic retrieval so relevant information can be surfaced when it matters. This is where RAG becomes essential. Instead of trying to train a model to know everything, the system retrieves only the most relevant passages from vast collection of documents, and based on the supplier, the risk dimension and what has changed. Then the LLM interprets not just keywords, it can understand whether the enforcement action was minor or systemic, whether a regulatory change affects a specific supplier category, whether repeated media coverage signals a trend rather than a one-off event, and critically, it does this with evidence. If the data is incomplete or ambiguous, the system flags uncertainty rather than fabricating conclusions, which is exactly what you want in risk management. From combining retrieval and reasoning, the framework transforms unstructured data from background noise into actionable early warning intelligence. That's what allows organizations to see risk forming, not just failing. And this capability is foundational. Without it, dynamic supplier risk intelligence simply isn't possible. Supplier risk is never one dimensional. Most failures don't happen because of a single issue, they happen because multiple risk factors compound over time. That's why this framework evaluates risk across four core domains, each representing a different failure mode in global supply chains. First is geopolitical risk. This covers factors like tariffs, trade restrictions, sanctions, regional instability, or policy shifts. A supplier might be operationally strong, but if they're located in a region facing escalating geopolitical tension, that exposure can quickly turn into supply disruption. The system continuously monitors external intelligence, so these changes are detected early, not after borders are closed or tariffs hit. Second is financial exposure. Here, we look beyond static financial ratios. The framework combines structured financial data with unstructured signals such as credit downgrades, market commentary, or analyst reports to identify early signs of financial distress. This allows organizations to act before liquidity issues become operational failures. Third is regulatory and compliance risk. This is especially critical in regulated industries. The system tracks regulatory changes, enforcement actions, warning letters, and litigation across jurisdictions. It doesn't just flag violations, it interprets regulatory direction, helping teams understand where scrutiny is increasing and which suppliers are likely to be affected next. Fourth is ESG factors. Environmental, social, and governance risks are no longer optional. Labor practices, environmental impact, governance failures, and ethical issues are increasingly driving regulatory action, customer expectations, and reputational risk. The framework evaluates ESG signals alongside traditional risk domains, ensuring they are part of the same decision context, not siloed or treated as secondary. What's important is that these domains are not assessed independently. The system looks at interactions between them. So instead of asking which risk category is the supplier in, we can ask how many multiple risks are evolving together and what does it mean for continuity and compliance. That's what makes the coverage comprehensive and the insights actionable. So how does something like this get deployed? The key design principle here is incremental adoption, not a big bang transformation. The framework is intentionally structured to move from proof to production in controlled stages. First is the assessment phase. This is about understanding what already exists. We start by evaluating current ERB and supply data availability, existing risk processes and governance requirements, priority risk domains and supplier segments. The goal isn't to redesign everything, it's to identify where early value can be delivered with minimal disruption. Second is the pilot program. This is where framework is validated in the real world. A subset of suppliers, typically high critical or high risk, is selected. The system is run alongside existing risk processes, not instead of them. This allows teams to compare insights, validate the explainability, and tune the retrieval sources and thresholds. Most importantly, it builds trust before scaling. Third is the scaling strategy. Once value is demonstrated, the framework scales horizontally. Additional supply tiers, risk domains, and data sources are brought in. Because the architecture is modular, scaling does not require redesign, it's configuration driven. At this stage, the framework becomes a continuous monitoring layer rather than a point solution. Fourth is continuous optimization. Deployment doesn't end at go live. The system is continuously refined by monitoring the detection accuracy and false positives, incorporating human feedback and overrides, updating data sources as regulations and markets evolve. This ensures the framework always stays relevant as risk patterns change. What's important here is that each phase produces value on its own. You don't need a full enterprise rollout to see benefits. Early pilots already improve visibility and response times. So implementation is not about adopting a new tool. It's about progressively upgrading how supplier risk is detected, explained, and acted upon without disrupting your existing operations. At this point, it should be clear that the framework is not just a technical improvement, it represents a strategic shift in how organizations think about supplier risk. The immediate value is resilience. By detecting risk earlier and explaining it clearly, organizations reduce exposure to supply disruptions, regulatory surprises, compliance failures, and cascading operational impact. Instead of reacting to incidents, teams can intervene before failures propagate across the supply chains. But the long-term value is even more important. This framework transforms supply risk management from a defensive control function into a strategic capability. When risk intelligence is dynamic, explainable, and continuous, organizations can allocate resources more efficiently, focus attention on supplies that truly matter, and make sourcing and qualification decisions with confidence. It also strengthens trust and governance. Leadership gains visibility into why decisions were made, auditors and regulators gain defensible evidence trails, and procurement teams gain a system that supports judgment rather than obscures it. Looking forward, this is what the future of supplier risk management looks like. No periodic scorecards, no static dashboards, but living intelligence that adapts as the world changes. A system that continuously asks, what has changed? Why does it matter? And what should we do next? As global supply chains become more complex and more volatile, organizations that rely on static risk models will always be one step behind. Those that adapt explainable AI-driven risk intelligence will be positioned to anticipate disruption, maintain compliance, and build supply chains that are resilient by design. And that's the shift this framework enables and why it matters beyond any single implementation. This framework represents a shift from reactive to proactive, from static to dynamic, from opaque to explainable, and explainable RAG is not a feature. It is an enterprise AI pattern. To wrap up, the core idea is simple. Supplier risk today is dynamic, multidimensional, and largely invisible to traditional systems. Static scorecards and periodic reviews were never designed for the pace and complexity of the modern world. What this framework demonstrates is a different path. By combining retrieval for grounding, large language models for reasoning, and explainability for governance, we can move supply risk management from reactive assessments to continuous intelligence without sacrificing trust, auditability, or human control. This isn't about replacing existing systems with human judgment. It's about augmenting decision makers with early signals, clear explanations, and defensible insights. So action happens before disruption and not after it. As supply chains become more volatile and regulated, the organizations that succeed won't be the ones with more dashboards. They'll be the ones with intelligence they can trust, explain, and act on. Thank you. I'm happy to take questions.